So here is the agenda. So first, we'll just give you a brief overview of our Snowflake Container Runtimes, and then we'll get into a bit of details on how we use Ray behind the scenes to optimize the data ingestion and implement distributed training APIs, and then probably we'll end with a small demo. So let's just get started. So Snowflake Container Runtimes, what is it, and then why is it, right? So before I answer that question, so let me just refresh you with some of the key challenges many organizations have to deal with when they have to do large-scale distributed training. The first problem is resource management. Organizations will have to find a way to provision and then manage their GPUs and then ensure the efficient utilization of that while keeping the costs in check. And then setup part, right? So it's a big hassle to figure out right set of packages for the kind of hardware that you have and then the frameworks that you're using, and then keep maintaining those packages by upgrading them and then doing security patches. And then after all that, then you need to go and then deploy and then manage services to orchestrate your compute, distributed training compute. So that's all big hassle. And then data handling is another key piece. You need a way to efficiently ingest the data so that you keep your GPUs busy. You don't have your GPUs waiting for your data. And then you also need to figure out a way to shard your data perfectly so that you can do distributed training on that. And then finally, fault tolerance. I don't have to talk much about it. It's non-trivial. The users will have to figure out a way to detect and then recover from those failures. These are all the challenges. And then Snowflake Container Runtime is a solution that is just gonna take care of all of those problems for you and then give you a production-ready data science environment just within a few clicks. So Snowflake Container Runtimes takes off all the heavy lifting off your shoulders and then let you focus on the key part, that is building and then training your models. So Snowflake Container Runtime, it is fully managed, so you don't have to worry about infrastructure. And then it is pre-configured, so you can get right into your workload without any hassles of setting up and then maintenance. And then obviously it has efficient implementations to ingest your Snowflake data for training. And then it also has distributed training APIs, which will just make it very easy for you to scale out your training jobs from single node to multi-GPU, multi-nodes. So here is the architecture of a high-level overview of the architecture of Snowflake Container Runtimes. So we use something called Snowflake Container Services. So Snowflake Container Services provides a Snowflake product that provides abstractions to provision hardware and then deploy and manage your containerized applications. So the Snowflake Container Services internally works with multiple clouds to provision hardware, and then they have APIs to deploy and then manage services. So using that product, so we deploy Ray, and then that's our setup. So once we have this all the setup ready, so we have Snowflake ML modeling APIs. So these APIs provide capabilities to build and then train classical ML and then deep neural network models. So these APIs are implemented using native libraries like sklearn, XGBoost, and then PyTorch. Distributed using Ray core APIs. And then in some use cases, we use Ray train and then Ray tune APIs directly behind the scenes. But most of our APIs are implemented using native libraries and then distributed using Ray core APIs on our service. And then at a very top layer, we have Snowflake notebooks that provides an interactive environment to run and then monitor your data science workloads. Here is another view of that system, which shows the data flow diagram. At the top, you can see the users interacting with the notebooks UI, and that's going to push down the execution of those notebooks, and then any further compute into our hardware and then software stack. So yeah, I'll stop there, and then my colleague Allie will walk you through the rest of the presentation.
Great. Thank you so much, Sravan, for that intro to the container runtime. And now I'm going to go a little deeper into some of the features that we support and how Ray is backing those. So there's a few things I'm going to talk about right now. The first is we're going to go a little bit deeper into the optimized data ingestion that Sravan was mentioning. And then we're going to talk about our distributed training APIs that allow for more seamless scale out across devices and nodes. And then we'll do a quick demo to show you examples of those things, and also that we're running in a more flexible compute environment where you can bring really any open source workloads as well. So first, let's talk about data ingestion. Obviously, Snowflake is primarily where a lot of people keep their data. So it makes sense that we'd want to make sure that we're going to have the most efficient possible retrieval of that data into your machine learning workloads. So we've just recently introduced a new concept called a data connector, and then this integrates with Snowflake data tables via Snowpark data frames. It also integrates with Snowflake datasets, which is a relatively new data object, an immutable version data object that's perfect for production machine learning workloads. And then you can convert your Snowflake data into open source data formats. So that might be a Pandas data frame, that might be a PyTorch data set, for example. And the way that we've implemented this behind the scenes on our container runtime is that we're using Ray data behind the scenes to make sure that you're getting really efficient throughput as using as many of your compute resources as possible. So we've used native Ray data sources to do that from Parquet files. We've also implemented custom Ray data sources to integrate Snowflake tables directly. So you might be thinking, okay, well, I could just do that. Why shouldn't I just use Ray directly? And you're certainly able to do that. But the reason you might want to leverage our data connector API is because you don't have to worry about the implementation, defining your own custom data sources, that kind of thing. You can just take your Snowflake data, turn it into a Pandas data frame or a PyTorch data set without having to think about it at all. So it's easy to use. It's also unified. We have multiple implementations. So this API is going to work inside the runtime. It'll use Ray. It'll be super efficient. You can also take it outside the runtime. It'll just use native Python libraries. You don't have to have a Ray cluster running. So you can bring your work inside and outside of Snowflake. And then, of course, we got a team of engineers working on this. So we're always also creating performance improvements. So we have some of our own performance improvements that we are doing on top of Ray data to make sure that we're operating as fast as possible for many, many use cases since we have such a diverse customer base. So this just highlights a couple different things. The first thing I want to point out is that it's going to be fast to use your Snowflake data from within Snowflake. So if you look at this chart, we have compute pool type on the bottom. The fastest way to ingest your data is with a high memory medium machine type. It took 19 seconds in a single node case. The exact same specs on an EC2 instance took 50 seconds. So, you're getting like a 2.5 times speed up just for using one node, no scale out, just same machine type, but inside Snowflake instead of outside of Snowflake. And then, of course, if you don't want to scale up, you can always scale out. Maybe you just want to ingest your data efficiently, but then you don't need a lot of CPUs. You can instead scale out to a few different instances for ingestion, scale back down, and you don't incur any additional cost because you're getting that 2x speed up. So what might you want to do with that data? Well, that brings us to our distributed training functionality, sort of the core of this talk. So like Sravan said, we are going to be introducing more and more distributed training APIs, and this will allow you to take your training jobs, bring them to Snowflake, keep them as close to open source as possible, and then we're really just managing the scale out for you. And the reason why it's useful to do this in Snowflake instead of on your own outside of Snowflake is we're backing all of the sort of things that, like they were saying in the talk this morning, that Ray framework by itself is missing. So you're operating in a secure ecosystem. You don't have to manage your own port authorization. You don't have to manage your own ingress or egress. We're doing all that for you. We're provisioning the resources for you. We're making sure there's no compute contention and that you have access to your entire compute pool. And then, of course, we've implemented it using Ray Core, so it's going to be very efficient if you're running on the runtime to access all of your devices and all of your nodes' resources. And then you're part of the Snowflake ecosystem, so you're going to get your native integrations also with the rest of our machine learning tooling, like the model registry. And we're building a lot of stuff, so more and more stuff can be integrated as time goes forward. So what this looks like is it's a pretty straightforward API where adding the ability for you to provide a scaling config for you to specify how you want your training jobs to be distributed, but then you just pass in a training function. So that's just going to be whatever code you want to run from within your trainer. And this is leveraging the Ray Core library behind the scenes to do that distribution of work across your cluster. we're also using some higher level APIs to like whatever is appropriate. We're about to introduce tuning, and we're going to use Ray Tune behind the scenes for that. So we're just managing all of that infrastructure for you. So I wanted to show a quick demo. So this is the Container Runtime notebook. So some of you may have already used Snowflake notebooks. They've been available for the public to use for a while now. But this is new, that you can run this on a SPCS compute, Snowpark Container Services compute pool, and that's how you get access to the more flexible computing environment, basically just a container image. And then you can choose if you want to run it on a GPU image or a CPU image, and then choose the compute pool. So, we're here now in the notebook on container space. We've arrived. And so this allows you to do just normal flexible compute operations. You can pip install whatever packages that you need to run your job. Of course, since it's Snowflake, it's extremely easy for you to grab your Snowflake session so you have access to your Snowflake data. So you can just define your Snowflake table name. This shows that new data connector API. So you just easily say, okay, take my Snowflake data, turn it into a pandas data frame. Here we're going to materialize 12 gigs of data, and it should take about 10 seconds. So yeah, it's done here in 11 seconds. These are some warnings that you can silence if you want to. You can actually see that it's letting you know that you've connected to a Ray cluster behind the scenes. And then using your Snowflake data, once again, you can train open source models. You can bring your own code, whatever you've been running outside of Snowflake, and you can run it here in Snowflake now directly. As many of you know, XGBoost, for example, will only use one device if you're on a GPU-enabled compute pool. So you can also use our APIs if you want to make sure that you're leveraging all of the compute available to you in your cluster. So this is, oops, I just ran the XGBoost one again. Here we're importing our XGBoost estimator. It has almost the exact same as API. You put in all of the XGBoost configs, but then you also just add this additional scaling config to, tell us how you want to distribute your job. I think this one's actually going to load all the data and run a little slower because it's such a small pint-size example that we don't really need to do the distributed API. But this should finish up here in a sec. And then for other, like for PyTorch, for example, it's the exact same story. You can load your data, and then you can define your own model and run your PyTorch open source workloads directly from within the notebook. This won't use Ray, obviously, except to load the data because you're running your own model that you've written yourself. But then here, if you take that same exact training function and then you pass it into a Snowflake-specific API, this PyTorch distributor API, you can tell us how you want to scale out, and we will make sure that we use all of the devices that you're interested in using on your behalf. So same training function. The only additional parameters are this scaling config, and then you modify just a little bit to say things like, get the data that you're interested, get the rank of your device. Like we pass all these convenient functions to you so that you can operate from within a distributed training context. And that's it. Thank you guys so much.